Honors Geometry students, welcome back. We are now starting Unit 11, which is all about surface area and volume. The first two class periods will be all about finding the surface area of prisms, pyramids, cones, and cylinders, and then we'll move into finding the volume of those 3D shapes. Our learning target is 3G. I can compute, solve, and analyze volumes of geometric solids. All right, and actually this is going to fit more into 3C where we're finding the surface area. So our entrance question for today is to draw a 3D representation of a room that has dimensions 10 feet by 12 feet and 8-foot high ceilings. Usually I've been skipping our entrance question, but since this one shows up later in our notes, I thought we'd go through it. We want to draw a 3D representation of a room. So this is going to be a rectangular solid. And you're going to start out by drawing a rectangle. All right. I'm going to draw another rectangle that's a little bit off center based on that, but it should be roughly the same size and shape. I'm then going to connect my corresponding corners. All right. We're told that we have 8-foot high ceilings, so that 8 feet is going to be a vertical piece. 8 feet, I'm going to use the single apostrophe mark for a foot. The other two dimensions are 10 feet by 12 feet. So that's going to be like the length and width of our room. So this piece here can be 10 feet, and this piece here, 12 feet. If you had the 10 feet and 12 feet flopped, that's okay because there's no indication of where those should go. All right, so this is our intro to 3D figures. So in this unit we're going to talk about, or in this lesson we're going to talk about prisms and cylinders. A prism is a polyhedron with two congruent parallel bases. The other faces are known as lateral faces. So basically, you know you're dealing with a prism if you see you have two congruent faces that are the exact same size and shape that are parallel to each other. So this guy here has two pentagons as the bases, so this might be called a pentagonal prism. All right, and all of those other faces are lateral faces, and we have a whole bunch of rectangles hanging out to make up our lateral faces. All right. The altitude is a perpendicular segment that joins the planes of the two bases, and the height, h, is the length of the altitude. So in this case, in this figure, we could think of this top and this bottom as our lateral, our faces, and then this would be our altitude, and however long that is our height. We'll come across two different types of prisms. We can have a right prism where the bases are stacked right on top of each other, forming a 90-degree angle. Or we can have an oblique where our two bases are not stacked right up on top of each other, and this is at a different angle. It's not a 90-degree angle. So it's more slanty. All right, a couple more terms before we dive into this. Lateral area is the sum of the areas of the lateral faces, so this would not include the bases. Okay, you saw just a moment ago that when I was tracing the lateral faces of the pentagonal prism, that all of those were rectangles. So it's like finding the areas of all those rectangles and adding them together. The shortcut would be to find the perimeter of your base and find the height of your prism. Okay, so you're going to find the perimeter times the height. So in that case, so I'll go back up. Hopefully I'm not making it dizzy. If I want to find the area of the lateral faces, what I would do would be to find the perimeter of this pentagon. So let's say we have 5s all the way around. 5 5s. So the perimeter is 25. Let's say that my height, the side connecting the two bases, is 10. So to find my lateral area, 25 times 10, or 250 square units. All right, if we want to find the surface area, that's going to be everything. all of our faces. Okay, so that's going to be your lateral faces and the two bases. It's going to be the lateral area plus 2 times the area of the base. And the base can be all sorts of different shapes. And think about in last unit, we had rectangles, we had triangle, we can have a parallelogram, we dealt with a rhombus, we dealt with a kite, trapezoid, and a regular polygon. And you might want to check out all the formulas that we had. I've posted those on Blackboard. If you want to have a quick reference to that, you might want to have that handy while you're doing your work. All right. So example 1, find the surface area of the room that has dimensions 10 feet by 12 feet with 8-foot high ceilings. All right, so this is the exact thing as our entrance question. So I'm just going to go ahead, copy that, and paste it down here. All right, so I'm going to start with this wall on the left-hand side. If I want to find the surface area, I'm going to find the area of all 6 of the surfaces and then add them together. All right, so if I'm looking at that left wall, the left wall has dimensions of 10 by 8, okay, or 80. My left and right are the exact same size and shape, so if I want to move in and deal with this wall directly opposite it, I know I'm just going to multiply this by 2, so 2 times 80, I get 160. All right, I'm going to deal with this front wall. All right, the front wall has dimensions 12 by 8. Okay, and 12 by 8 is going to be 96. If I want to deal with both the front and the back wall, I know I have 2 of them exactly the same size, so 2 times 96, or 192. All right, so now I'm going to get in to the ceiling. The ceiling has dimensions of 12 by 10, or 120 square feet. The floor has the exact same dimensions, so I want 2 of those, so 2 times 120 gives me 240. Okay, to find my total surface area, I'm going to take the left and right, the front and back, the floor and ceiling, so top and bottom, add those all together, and I get 592, and I'm dealing with square feet as my total surface area, the area of every single surface. All right, cruising along. Example 2, we're going to find the surface area of the triangular prism. All right, so our base is this lovely triangle. Okay, and I know I'm dealing with a triangular prism because I have 2 of them. Exact same size, exact same shape, they are parallel to each other. Okay, so it just happens to be resting on one of its lateral faces instead of on its base, but that's okay. All right, so we might choose to start with the triangles. Area of a triangle is 1/2 base times height. All right, so if we're dealing with our base and height, okay, my base, that looks like 4 meters, but I don't have a right angle, so I don't have my height. Okay, if you notice, all 3 sides of my triangle, even though it's kind of listed out differently, they are all 4 meters. So that means this is an equilateral triangle, which means that each angle has a measure of 60 degrees. I drop down the perpendicular for a 90-degree angle, And now I have this lovely 30, 60, 90 triangle. Thinking about the pattern, across from 30 is x, across from 90 is 2x, and across from 60 is x root 3. So x root 3 would be the height of my triangle. All right, so this entire length is 4. So half of that would be 2, so x is 2. You could have also set up the equation 2x equals 4 and solve for x that way. If x is 2, I plug that into my x root 3, so my height is 2 root 3. So if I want to find the area of one of my triangles, I'm thinking 1/2, my base is 4, my height is 2 root 3. And now I'm going to simplify it. Okay, everything outside the square root can be multiplied together. So 1/2 times 4 times 2, that gives me 4 root 3. I know I have two triangles. So to find the area of two triangles, I want two areas. Multiply all this junk by 2. 2 times 4 gives me 8 root 3 square meters for the area of my triangles. Those are my bases. All right, so now I'm going to find the area of the sides, those lateral faces. All right, and we see we have these triangles hanging out here. Okay, you can find the area of those triangles or the rectangles individually, or we can use our formula, which is perimeter times height. Now the perimeter of my triangle base is 4 plus 4 plus 4, or 12. Okay, the height of my prism, that's the side that joins together the two bases, and that's 11. Okay, so my lateral area is 132 square meters. So to find my total surface area, I need to add those two things together. All right, so 132 plus 8 root 3, those are not like terms. So think of it like 132 plus 8x. Couldn't combine those, same thing is happening here. Typically we'll throw that in parentheses so we can talk about that as a unit as being square meters. All right, moving along. Surface area for a cylinder. All right, so surface area of a cylinder, we see we have two shapes, one on the top, one on the bottom. It's going to be our circles, so 2 pi r squared. And then this piece here, it's kind of a folded up rectangle. And to find the area of that rectangle, it's going to be 2 pi r h. Okay, and then I'm going to transition over to YouTube real quick to show you this quick little video of where that formula actually comes from. It's hard to visualize. All right, so we see our two circular bases and then that wrapped out rectangle. And then notice that piece that's curving around, that's like the circumference of the circle. So that's where the 2 pi r is coming from. And then the h is the height of the cylinder. So we see two circles, so that's where the 2 pi r squared comes from, two areas of the circle. And then the length of the rectangle corresponds with the circumference of the circle, so that's 2 pi r. And then the height of the rectangle corresponds with the height of the cylinder, so that's where the 2 pi r h comes from, finding the area of that rectangle. All right, so perhaps that animation helped you out a little bit. Okay, so that's our formula here. R is going to represent the radius of our circle, and h represents the height of our cylinder. Okay, so we're going to find the surface area of a cylinder if the base has a circumference of 16 centimeters and the cylinder has a height of 20 centimeters. All right, so if we go straight by the formula here, 2 pi r squared plus 2 pi r h, we can plug in the height right away, but we don't have our radius. We do know the circumference. Thinking about with our last two units we dealt with circumference, formula for circumference that involves radius is 2 pi r. So we're going to plug in 16 for big C. So 16 equals 2 pi r. We want to get r all by itself, so I'm going to divide. I'm lazy and do this all at once. I'm going to divide both sides by 2 pi. If you're hitting up your calculator, please make sure that you put parentheses around the 2 times pi. Otherwise, what your calculator is doing is it's dividing by 2 to get 8, and then multiplying by pi. All right, so when we do this, we should have about 2.55, and we're dealing with centimeters, as our radius. Now that we have 2.55 centimeters as our radius, we'll plug that in two places. All right, so now we'll plug that in. 2 pi times 2.55 squared plus 2 pi times 2.55 times our height of 20. All right. Let me get this going on my calculator. Sorry, taking a little longer. There we go. And I end up with my surface area is about 361.3, and since I'm talking about area, that's square centimeters. Okay. Last one, we're looking for our lateral area. Lateral area. You want to find the perimeter of your base times the height. Well, if I look here, I notice that I have 2 triangular faces, and to find the perimeter of my 2 triangular faces, I'm going to take 8 plus 12 plus 8 for 28 for my perimeter. The height is the piece that joins together my 2 faces, so in that case my height is 10. So if I want to find my lateral area, I'm thinking P times H, so 28 times 10 gives me 280 square centimeters, and that's my lateral area. If you didn't want to use the formula or you couldn't remember the formula, you could have chosen to find the area of that bottom rectangle, 10 by 12. Find the area of this back slanty rectangle, which is 8 times 12. 8 times 10. All right, and then find the area of this rectangle, which is 8 by 10, and then add them up, and that would get you the same place. All right, your homework is to check out section 6.2, and we're going to do 2 through 36 even. So let's take a look at the homework and let's work through a couple of them. All right, just to get you started. All right, so number 2 says, all right, each structure is made of 12 unit cubes. What's the surface area of each? All right, so if I look at this one, my surface area, all the surfaces I can see. So in the front, I can see 6 cubes. In the back, I would be able to see the same amount, so 6 times 2 for my front and back would be 12. So all of that is taken care of. All right, on this right-hand side, I can see 1, 2, 3, 4 cubes. I assume that on the left-hand side, I'd be able to see the same thing, so 2 of those for a total of 8. Okay, and then up top, I can see 1, 2, I can see 1, 2, 3, 4, 5, 6 different cubes. I assume I would be able to see the same on the bottom for 12. To find my surface area, I would add those up, and I would end up with 32 as my square units as the surface area. All right. Let's see, what else should we take a look at? Okay, for number 6, if you're looking for your lateral and surface areas, okay, let's start with surface area. This is a cylinder, so you'll want to be thinking about 2 pi r squared plus 2 pi RH, okay, where 2 would represent our radius and h would represent our height. If you're talking about lateral area, that's going to be everything except for the two bases. So lateral area, you're going to, if you consider the whole formula, 2 pi r squared plus 2 pi rh, well, each of those circles is a pi r squared, so I want to get rid of the 2 pi r squared, so ignore the 2 pi r squared portion of the formula. Lateral area would just be that rectangle that curves around to make the sides, and that's 2 pi rh. Again, think of 2 as your radius and 8 as your height. Let's see, what else do we want to take a look at? Okay, for number 12, notice that you have a right angle hanging out here. Okay, so we see a right triangle for our right triangular based prism. In order to find that missing side, we want to hit up with the Pythagorean theorem, a little a squared plus b squared equals c squared action. So we're looking for one of our legs. So you could think a squared plus 4 squared equals 5 squared to plug in there. And then here we're trying to find the lateral area. Lateral area, remember, is the perimeter times the height. So you would want to find the total perimeter of your triangle, and then the height would be the side joining together your two triangular bases. All right, so that's enough to get you started. Please reach out if you have any questions. I will see you online. Bye.